you're going to be setting up these PWM registers. You're going to be setting up EPWM 12 for this exercise 2 in homework 2. And the method, I wanted you to kind of play in what's called the register view, and I'll show you what I mean by that. Okay, so I made a new homework starter, and I'm just going to bug the code. We still, you know, we're gradually getting you understanding what this thing is, this register, and how we set up these peripheral registers and all this good stuff. It's just going to take some time, okay? You just, with you setting up the PWM registers, and then the next week you setting up the ADC registers, it'll become a lot clearer to you as you do it. You know, we'll go through stuff here in lecture, but the best is just to start playing with these. And sometimes this isn't seen. If you don't see this right here, these registers, when you get into Code Composer, okay, you can, of course, go here, view registers if you don't see it on your laptop. And the idea with this first part of this problem 2 was that you're going to set up EPWM 12 in main. And what I mean by that, where I want to try to get you putting all your initialization code, you'll see me say this a lot in the homeworks and in the labs, put your initialization code down here under init serial. That's I mean, if it was above init serial, it probably wouldn't matter too much, but I've just kind of made this section where I'm going to tell you to put all your initializations. It's just not usually a good idea to put it up here at the top of main, because definitely you cannot put it before init system control right here. Init system control, when this processor boots up, it doesn't know what, well, you have to tell it what clock frequencies out there and all that kind of stuff. So your processor's running slower before you run that init syscontrol command. Okay, so that's a really important one to run first. But anyway, so what you'll find me asking you all the time is to put your code, your initialization code, somewhere below init serial, right here, and before, for sure, before you enable the interrupts right here. Okay, before this EINT instruction. Okay, so the perfect place to put it is then right here, right after init serial. So what you're going to be doing as you march through the first exercise of homework 2 or exercise 2, you're going to be setting up this EPWM 12 regs register, okay, and the appropriate registers of EPWM 12. Now the great news, look at all these registers. The good news is we don't need all these registers. They are for different functionality of this PWM register. If we got more advanced with this PWM, if we started driving, PWM, our big use of that will be to drive motors. And we'll talk about that more as we get farther into PWM. But if you needed to drive 3-phase motors, that's these, have you ever heard of brushless DC motors anyway? They're very complicated in how to drive compared to our little DC motors that we're going to use in class. Okay? 3-phase, there's issues, you got to keep the frequency of those phases pretty much 120 degrees out of phase all the time and all this kind of stuff. Much more complicated PWM for 3-phase motors. And that's really what these 28 series DSPs, that was one of their main product lines, right? That's where most people buy these, is to drive 3-phase. Well, I don't know what most, I never asked TI. But it's definitely all the capabilities of this chip are really focused on driving 3-phase motors. Anyway, so that's why there's all these other registers out here that you are probably not going to, well, unless we do something special in a final project, you're not going to use. And so what I do is I specify the registers that you're going to use 2 ways. One, in the lab, I say set up TB control, TB-CTL, set up ACTLQ or whatever it's called, right? I tell you the register which one to set up. The other way I specify that to you is in the reference guides. So if you go to the website and you go to my condensed references, see right here, and we go to the PWM condensed reference, you go down to the register section of this document, and let's see, one more page down, and here's all the registers possible, okay? The ones we're going to use, the ones we aren't going to use, I cut out of this document. So the way you find out which are the important ones for our class is to go to the bottom of this condensed ref and find the ones I've included. There's not nearly the 100 here that you saw, or whatever it is, 50 registers that are part of each PWM. Is that kind of making some sense? So I've sectioned it off for you so we don't have to go dive through all those other registers. And personally, many of those registers I haven't played with. Okay? I haven't used this for a three-phase motor control and things like that. Okay, I want to. That's something that, on a buckets list for me. But anyway, when it comes to work. But we haven't got to that really yet in my career. So anyway, that's what's going on there. Now, back to Code Composer. So here, you're going to set up the timer base. Let's see, boom. And see, if you remember, you do this and dot and wait a little bit, then it will pop up the options here. And then timer base control dot bit dot. And then see, all these things are part of this register. Now, how do we know what to set all these parts to? Okay, one, again, I will say in the lab, set clock divide to 1, or set clock divide to whatever you think it needs to be. Okay, and you'll have to think about that, right? In homework, problem 2, I say set clock divide to 1. So what is this divide, right? We kind of got to talk about that too. But I tell you what to set that to, or I say figure out what you need to set it to. So if I don't say something in a homework, like if for some reason I don't say what to do with period load, LD, PRD, LD, whatever that is, then you just leave it alone. The default, it's whatever it is by default is what it needs to stay at. Does that make sense? Okay. How would you, if you didn't have me in my lab assignment telling you how to do it, how would you do it? You would go look at the user's guide and you would have to read about it. You kind of go down to the registers. Where'd it go? You would, let's find clock divide. Here, let's go back up. So we go to the register section. Now, of course, there's explanation here too. This explanation down here talks about, in general, what the different registers do too. So you do read this part, and I give you reading assignments of the condensed reference. But then the most of your information is found down here in the register section. And so sometimes in my condensed ref, sometimes these go buttons work, sometimes they don't. You may have to search, by just put TBCTL in search and find it that way. Let's see if the go button works for it. Yeah, it does for that one. Good. Yeah, what's your question?
Will we ever be looking at the diagrams at the top early in the document?
Definitely.
Okay.
Definitely. You should definitely. We'll get into those in lecture for sure. But yeah, you should be reading. Worst case, you should skim through it to see where different things are. Another way to know what TB control needs to be set to, you can search for it in those upper parts.
I meant
right?
the block diagrams.
Block diagrams.
If you go all the way to the top. Yeah, like those.
Well, what this is this is an overview of all your signals. And sometimes you may need to look at these, okay? But again, some of these are really complicated until you really get a good understanding of what the PWM does. That's pretty confusing what that all is, okay? So no, do you have to before each lab understand exactly what every signal means in this diagram? No. Did I answer your question? Or?
Yes, thank you.
Yeah, okay. Good. Because I would have to go read. I have no clue what the ECC double error is or whatever, right? So there's some things in here that so what happens is you try to do something with the PWM, right? And if it starts giving you trouble when you start running something, you're like, well, what's happening? What's doing that? And then you have to go back to the data sheet and dig into it some more and understand that a little more clear. And then we try that, oh, that fixed it, you know? And then you go on and maybe you get a project with 3-phase motor control, right? And what you think the PWM should be doing isn't really happening. You're looking at on the oscilloscope and there's a delay. We're not getting 120 degrees phase, we're getting 125 degrees phase shift or whatever it'll be, I don't know. And you're like, oh, I'm doing something wrong, so I'm gonna go back to the data sheet, dig through it again, read it, and then reread it, and then reread it, you know? So you're lucky in that that's what I've done already for you guys, right? And I'm gonna teach you those parts. But when you're out there on your own, right, working on this stuff, and you just got this little glitch, and boy, what's going on? You're gonna be digging through this data sheet again, trying to figure, oh, that's what that, you know, whatever means, right? And let's try that. Oh, that fixed it, you know? So that, I do that all the time. I do that all the time with these chips. There's so much complexity inside them. You just can't, you can't just go digest the whole data sheet before and understand everything before you start programming the thing, right? You just can't do that. You just got to start trying things, and that's how you learn what these registers are doing sometimes. Okay? All right, good. Yeah, all right. So where was I? Okay, back to the code, right? All right. And so you're going to set these all things up. Clock divide happens to be, to set it to divide by 1 is actually 0. Like, would you ever want to divide by 0? No. So usually a divide register, if you set it to 0, if you don't, you know, if it didn't use 0, and clock divide was divide by 1, you're wasting a bit, right? You're wasting if that's 3 bits, clock divide. You have 8 options, don't you? If you ignore 0, then you only have 7 options, don't you? So usually they use 0, and that's a divide by 1, all right? So it's whatever, yeah, anyway. So that's what's going on there. Just to make your life a little more confusing. 0 is divide by 1. But it also specifies that. If you go to the register setup, clock divide by 2 is when you set it equal to 1. Clock divide by 4 is 2, etc. So it would show you in a table. So you're going to set all these things up, you know, so EPWM, 12 regs. You're going to do the different things I tell you to do. Bit, and this is the control. There's a free soft setting. You're going to read my homework assignment, and you're going to set this to something, right? And all the different registers that I ask you to set up. I tell you to 0 the count. So you'll be setting PWM 12 regs by, I think it's TB counter. Is that what, let me see. Break. Oh, right, sorry, what did I forget? Oh, semicolon, thanks. Dot. Yeah, and then is it TB counter? Yeah, right there. I say to 0 it. Well, that's easy. Put a 0 there. In other words, so you're going to do all the settings that I tell you to do, and then before we even try out the PWM to run to make it, what we're going to do is we're going to be dimming an LED with this PWM. We're going to make the LED really, very not bright at all, and then make it brighter, 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 and then just go up and down, oscillating the brightness of the LED is what the final part of the exercise is. Well, before that, I asked you to go to these registers and manually change things. So this is a really nice option, but you got to remember that there is a load of registers out there. So, and the refreshing of those is a little problemsome, especially when we use our little inexpensive JTAG. So there's a little trick I think that'll help you out. But notice, see, we just got all these registers. Now, good news is we're not going to get into many of these, but we've got all these to check out. We'll be getting to the ADC soon. And so here's all the ADC regs. Where are they at? Right there. ADC results regs, ADC setup registers, and all this great stuff. We'll be using the EQEP later on. We may use the captures. We're going to be using the DMA later. So we do use a lot of these, but definitely not all. The quadrature encoder peripherals, we'll be using those. we've already used the GPIO registers, haven't we? For turning on LEDs, turning off LEDs, reading a switch, etc., right? So anyway, so that's all out there for you to view. SPI, that's what we'll be getting into, this SPI serial port. Well, once you get this guy set up, what I want you to do in this exercise, go to EPWM 12 regs, and see here's all the registers that are part of EPWM 12. I haven't set it to anything, so they're all zeros right now. But what I'm asking you to do in this exercise is come down here to TB compare A. Okay? And I want you to set these values manually by just typing in numbers and trying them out. And so let's look at one other thing just to show you here. We can also, this right now is being displayed in binary, okay, what the bits are of compare A. You can right click on compare A and say number format, and you can make it display in decimal. Okay? Or if you like hexadecimal, which I do, but anyway, you could display it in hexadecimal, or you could go back to binary, whatever. So just remember that. You click on the thing you want to change, and you change the number format. We'll put decimal there. Now this is a little bit of a weird register. We're not going to use this part of the processor, but there is what's called a high resolution PWM signal also. And so just so you know, this compare A register is a 32-bit register, but we're only using the upper 16 bits of it, which is this compare A. So what we'll end up doing, and the lab tells you this, and the homework tells you this, that we're going to type into Code Composer, oops, I went wrong. Type into Code Composer, when we want to set compare A, we're going to say EPWM 12 regs dot compare A. This gets a little confusing because you think that's it, but no, compare A is actually 32 bits, so you got to say .bit compare A to get to it. They probably should have named this a little bit better, and then you set to that to some number, whatever, right? Okay, that's how that works. Now, what the register, which is the period, we're going to come to what this period's doing. EPWM 12 regs. The period is just 16 bits. So you would just say TBPRD, and just, you don't have a dot bit. You can try, so you can hit dot like this and nothing shows up. Or if you do say dot bit on accident, say you do this, just type this all in, equals some number, 1, 2, 3, 4, 5, 6, whatever. Notice how these, do you see that these are black and not blue, the text right there? That's telling you that either you have a typo or there is not a dot bit in the period register. Okay? So that a lot of these things on the lines of code are really helpful for you. So watch for those things. And so this one is just a 16-bit. And of course, we can come back to our document and find that. If we go to the period register, so let's see if we can get to it quick. Go here, click, and down in here, where's the period register? TB period, we say go, and see, this is just a 16-bit register right here. All right, see 0 through 16, where if we go down and look at what compare A is, see, compare A is a full 32-bit register. See that? Okay. So each one of these registers have these, whatever you want to call this table or this figure right here, explaining what all the pieces are. The other cool thing, let's go back. The other cool, oh no, that's not what I want to do. All these bit fields that we're going to be setting, the very good thing that TI does is they synchronize the source code we see up here with the data sheet. Okay, meaning if we go to what would be another one, TB control 2 or whatever, and actually let's just go to TB control, and then look at all these. We've got this thing, this section of the register called clock divide. We got a section of the register called high speed clock divide, and so on, right? And what TI does is if they name it clock divide here in this table or figure, that's also how they're going to name it in your source code. So you can go one for one back, or like counter mode right here. So if we go back to our source code and we do this again, we say EPWM 12 regs dot tbctl dot bit dot, and then see here all those. There's the counter mode, for example. And so they do a good job of naming those correct. And like we found a bug in there that they didn't name it correct, we would probably send it up to TI and they would change it in their next version or something like that because they want to keep that consistent. Okay. Then back to why I brought up the board here. So what I asked you to do and where the problem came in was, I wanted to run this code. Let's see, can I free soft? We'll just set that to 0 for now. That's not the correct setting, so you guys figure that out. Put a semicolon here. Let's see if that, well, it won't work quite right, but let's build this. So we're going to terminate, or we can just, actually, if you guys know, if you're already bugging your code, you can actually, instead of terminating and then hitting the bug again, you can actually just hit the hammer here, and it'll compile, and it'll say, hey, you already got a debug session going. Do you want to download your code? So that's another little feature. See here, file you are debugging has been modified. Do you want to reload this file? Yes, I do. So it's just one less step, but anyway. Okay, so yeah.
Would you mind explaining again what's the significance of setting that register to a certain number?
Okay, I'll get to that. Okay, hold on, all right? Let me just show you this first, and then we'll come back to that, okay? And if I don't answer your question, ask it again, okay? All right, so I'm running now, and what I was hoping it would happen here is if we came over to these registers, for example, am I at PWM 12? I am there, yes. And so see, some of this has got changed. I set that TB control and all that good stuff, the counter. But now if I refresh, that's what these two buttons are. There's refresh and continuous refresh. Continuous refresh is very nice. It updates your variables. You can put your global variables here in expressions. You'll be using this a lot later on this semester. Registers here, if I put this to continuous refresh, the problem is it wants to refresh all these registers, and there's a load of them out there, aren't they? And so let's see if it did a refresh down here on TB control. I'm sorry, on TB period. See, it's still, even though I set compare A to something, it's not showing. Sometimes you can hit the single refresh and it shows, but it's not. Let's even try to set compare A to something. Or let's do period first. Let's set the binary, so number format, decimal. And now I can type in, just say 2000 or something. And see, it's not updating here, is it, for us? Even if I hit the refresh, it's not showing me that it's 2000. And compare A, same thing. I could set that to 1000. These are not the right answers for the homework. Oh, there, see, then it finally, it updated there, but it didn't update down here. So it's having a little bit of issue updating things here. What hopefully works for you. Now, if it's not updating right and you're seeing the correct response from the LED, let's say you set the compare A to a smaller value and the light gets dim in this exercise, then you can just say, well, this isn't refreshing right for me, and still demo it to me, okay? But one way to try to get this to refresh for you is the following. And you only, well, and the problem is we're not running any code that's talking to EPWM 12 right now. That's the problem. And so I did a step, one thing ahead, I guess, so if you want to call it that. Later, at the end, you're going to be talking to EPWM 12 every 1 millisecond, changing its duty cycle so that the light gets brighter and then dimmer, brighter and then dimmer, okay? So you won't have that problem. But anyway, so what I ask you to do in the homework assignment to try to fix this problem is take this assignment of TB period, where's it at? Right here. Let's just take this guy. And just to kind of trick the processor or whatever you want to call it to say the code so that you do this every time, just throw it here in timer 0 or something. And let's write to the period every whatever number of milliseconds. Just keep on writing to it, and then hopefully that refresh will then show us something in the register view is what I'm trying to get at. So this is what I'm asking you to do in the homework. Let's see if it works here. Watch it not, right, while I'm debugging this. All right, sure, we want to save that. We're going to buggy. I could have just hit the hammer. I did it the wrong way, or the slower way, anyway. All right, get that down there. Let's see now if that refresh works. So I'm just writing that same value to the period register. Let's go down. It worked on some people's laptops over before. Let's see. Go down to compare. Yep. See, it got the value there. And is that? Yeah, I think that's what I put in there. Now, if I put something compare A, and I hit the refresh. See, it's still giving us a little bit of trouble. It's refreshing up here, but not refreshing down here. Let's see. But anyway, yeah, refresh. Oh, come on, be good to me. Anyway, so yeah.
I got it to work if you pause the program and then change the value.
Pause it. Yeah, that's right. Yeah, that's another way to do it. You're right. So we can just pause. Yeah, there you go. And then it refreshed. Very good. That's another trick. Right. Good. See, pause, refresh, and then run again. And see, then you got your right value there. Excellent. Excellent. So, I wanted to go through this so it didn't give you a huge headache getting started in that homework number 2. Our debugging code is hard. Okay? And you should not expect everything to work exactly correct when you're, what am I trying to say? What's happening is this JTAG is halting the CPU, well, not really even halting. It's going and talking to all this memory while your code's running. Okay? And sometimes, depending on how you how the compiler optimized your assembly code, things could be in weird places when it goes and reads one of those variables or reads one of these registers. So most of the time when you're debugging, what you see in Code Composer is correct. But you always have to have in the back of your mind, hey, is that something going on with the debugging issue? Is it a debugging issue or is it my code issue? You always kind of have to have that in your head a little bit. Right now, let's assume it's, well, probably more than likely, you guys are just starting, more than likely it's a code issue, isn't it? But just always, debugging is not perfect, is I guess what I just want to say. Okay, just always have to keep that in mind. Good. Just imagine yourself debugging a program for Windows, for Linux, and all this kind of stuff. It even gets more complicated than this. Okay? So anyway, so you always have to kind of keep that in mind. Great. So